Lesson 6, Advanced Integration Techniques, Recurrence Formulae, Part 1. Example 1. If in equals the integral of sine x to the power n dx for n greater than or equal to 0, show that in equals minus 1 on n cos x sine x to the power n minus 1 plus n minus 1 over n in minus 2 for n greater than or equal to 2. Hence show that if in equals the integral between pi upon 2 and 0 of sine x to the power n dx for n greater than or equal to 0, then in equals n minus 1 over n minus 2 for n greater than or equal to 2. And hence show that I6 equals 15 pi on 96. Okay. Now, what we'll do here, first of all, we'll take that integral and we'll break it up into two parts. So in is equal to the integral of the sine of n minus 1x sine x dx. Now it's important you know how to break that part up. Now we're going to use integration by parts formulae, which is u dv equals uv minus the integral of v du. My u is going to be equal to the sine n minus 1x, and my dv equals sine x. Now just be very careful here when you integrate. I'll differentiate first. Du equals, now that'll be n minus 1. Now this will be the sine of x to the n minus 2. Look inside and differentiate that, and you just get positive cos x. Now here, the v, now when you integrate that, you'll get minus cos x. Just watch the sign. So our in is equal to uv, which is minus cos x sine n minus 1x. Now then it'll be minus, but this will change to a plus. We'll take that n minus 1 out the front. So it's plus n minus 1 integral of the sine of x to the n minus 2, and cos x times cos x is cos squared x dx. Now we rewrite, I'll just do a ditto here. This is a plus n minus 1 integral of sine n minus 2x 1 minus sine squared x dx. I'll rub that out, hang on. It's a bit messy, isn't it? Okay, we'll make that a sine squared x okay, now we're right to go. Now that's equal to plus n minus 1. Now when you multiply that by 1, that gives you the in minus 2, and then have a minus n minus 1. Now when you multiply that by that, becomes sine to the nx, which is in. Okay, now we'll take that across the other side and we'll get in plus n minus 1 in equals minus cos x sine n minus 1x plus n minus 1 in minus 2. Now all this becomes in, so in equals minus 1 on n cos x sine of n minus 1x plus n minus 1 on n in minus 2. Now when you want to work out the integral, the definite integral, of pi upon 2 to 0 sine n x dx. In will be equal to, now when you put pi upon 2 in here, right, the cos of 90 is 0, making that 0, and of course when you put the 0 in, this makes it 0, so all that will go out, so you'll simply get 0 plus n minus 1 naught n in minus 2. Alright, which makes it easy to calculate what I6 equals. Right, so here we go with I6. I6 will be equal to 5/6 of I4. I4 will be equal to 3/4 of I2. And I2 will be equal to 1/2 of I0. Now I0 is simply going to be equal to, now when you put in 0 into this, right, and this one here, this will become just a 1, so that's going to be equal to pi upon 2 0 of 1 dx, and of course that simply becomes x between pi upon 2 and 0, which equals pi upon 2. So we have that I2 is equal to pi upon 4. We have that I4, which equals 3 pi upon 16. So we have find that I6 equals 6 times 3 pi upon 16, which is 15 pi upon 96 as required. Example 2. If In equals the integral of sec x to the power n dx for n greater than or equal to 0, show that In equals 1 over n minus 1 tan x sec x to the n minus 2 plus n minus 2 on n minus 1 In minus 2 for n greater than or equal to 2. Hence show that if In equals the integral between pi upon 4 and 0 of sec x to the power n dx for n greater than or equal to 0, then In equals the square root of 2 raised to the n minus 2 over n minus 1 plus n minus 2 over n minus 1 In minus 2 for n greater than or equal to 2, and hence show that I5 equals 1/8 outside of 7 root 2 plus 3 log root 2 plus 1. Now we're going to split the integral up in a different way. We're going to say that In equals the integral of sec n minus 2x times sec squared x dx. Then using the formula, u dv equals the integral of uv minus the integral of v du. We'll let our u equal the sec of n minus 2x, and our dv equals sec squared x. So our du equals n minus 2 sec of n minus 3 x times sec x tan x, and our v equals tan x. Putting this in the formula, we get that In is equal to, now it's be u, which is right around the other way, or rather it's tan x sec n minus 2x minus, now I'll take the n minus 2 out, n minus 2 outside of, now this becomes now n minus 2 here, sec of n minus 2x, and that by that gives me the tan squared x dx. Now that becomes minus n minus 2, and this is sec of n minus 2x, This becomes sec squared x minus 1 dx, which equals minus n minus 2. Now this will become a sec nx, so this is in, and a minus gives you a plus, and this becomes n minus 2 in minus 2. Taking this across the other side, we're going to have in plus this one, n minus 2 in equals the tan of x, the sec of n minus 2x plus n minus 2 in minus 2. Now this becomes n minus 1 in equals all this. So in equals 1 on n minus 1, the tan of x, sec of n minus 2x plus n minus 2 on n minus 1 in minus 2. Okay, now working out the definite integral, that is the integral when pi upon 4 of 0 of sec nx dx, that will be equal to 1 on n minus 1 tan x sec n minus 2 x pi upon 4 and 0 of plus n minus 2 over n minus 1 in minus 2. Now putting the tan of pi upon 4 is 1, the sec of pi upon 4 is root 2, so that simply becomes root 2 to the n minus 2 over n minus 1 plus n minus 2 over n minus 1 in minus 2. Okay, now we've got to find out what I5 is. Well, I5 is going to be equal to root 2 cubed on 4 plus 3/4 of I3, and that becomes root 2 on 2 plus 3/4 I3. I3 is root 2 on 2 plus a half of I1. Now I1 equals the integral of sec x dx between pi upon 4 and 0. Now, it's a neat way of doing this. You can multiply top and bottom, or numerator and denominator, by sec x plus tan x. Sec x plus tan x dx. And by doing that, when you differentiate sec x, you get sec squared x, which is this one. When you differentiate sec x, you get sec x tan x, which is this one. When you differentiate tan x, you get sec squared x. So this is the derivative of this. So this is a log function. So this is the log of sec x plus tan x between pi upon 4 and 0. And on substituting that in, you get the log of root 2 plus 1. And of course, sec x is 1, the log of 1 is 0, so it just becomes log of root 2 plus 1. So I3 is equal to root 2 on 2 plus 1/2 of the log of root 2 plus 1, which is root 2. Okay, so I5 is root 2 on 2 2 on 2. So root 2 on 2, this one here, plus 3/4 of root 2 on 2 plus 1/2 of the log of root 2 plus 1, which is root 2 on 2 plus 3 root 2 on 8 plus 3/8 of the log of root 2 plus 1. Of course, this now becomes, that will be 7 root 2 on 8 plus 3/8 of the log of root 2 plus 1, which is our result 1/8 of 7 root 2 plus 3 log of root 2 plus 1.